Hello, students. Welcome to video lesson 3.7. We're the first part of video lesson 3.7. We're going to continue our discussion of triangles. And today we're going to talk about a special relationship that triangles can have to each other called similarity. Okay, so we're going to talk about similar triangles. It's a specific application of similar polygons. Any shapes can be similar. You could have similar pentagons, for example, 5-sided shapes, or similar octagons, 8-sided shapes, and so on. Basically, all that it means for two polygons or two shapes to be similar is that they are exactly the same shape, but not necessarily the same size. Okay, so one is just a bigger or smaller version of the other one. Okay, so you could shrink one of them down to get the other, or take the smaller one and blow it up, scale it up, and get the bigger one. Okay, so similar means they are exactly the same shape, but they're not necessarily the same size. Okay, it is possible for us to have triangles that are not similar, of course, right? Like I could make a triangle that looks like this, and then I could make another triangle that looks like this. And these are both triangles, but they are certainly not similar, right? There's no way that I can just expand or shrink down one of them to make the other one. Okay, these are not similar triangles. What I have marked here, these are similar triangles. Okay, triangle ABC and triangle EDF. These are similar triangles. One is just a bigger version of the other one. Okay, so two things that need to be true in order for triangles to be similar, or shapes in general. All of the corresponding angles need to be congruent. Okay, so if two triangles are going to be similar, their angles have to be congruent. Okay, so in this case, I have angle A here is congruent to angle E. They're the same measure because they're marked with the one arc. Angle B is congruent to angle D, marked with two arcs. Angle C congruent to angle F. Okay, so all three corresponding angles are congruent to each other. Okay, so that's this part. All corresponding angles are congruent. Second part, all corresponding sides make equal ratios. Now, we're going to talk more about these equal ratios in our next video. But for today, all we're going to try to do is we're going to try to figure out or identify what are our corresponding sides. Okay, so in this triangle, for example, if I look at side AB with, and then I'll put the segment mark over it here in just a second. AB, side length AB, or segment AB, that side length corresponds to what side length in this other triangle? Well, AB goes between the green 1 marked angle and the purple 2 marked angle. So I should do the same thing in this triangle, 1 green mark, 2 purple marks. I'm using this side here, ED. So AB corresponds to ED. Okay, so that's what we mean by corresponding sides. And in your homework, when you're asked to identify corresponding sides, I want to see a lot of statements that look like this. Okay, like this. This is you identifying corresponding side lengths. Side length from this triangle, side length from this triangle. Okay, they correspond to each other. Like I said, we will talk about the equal ratios part in our next video. But for today, we're just mainly worried about where are these pieces? What do similar triangles look like? Okay. And not only that, but we're also going to focus today on similarity statements. Okay, now we spent some time in previous sections of this chapter talking about congruence statements, right? Saying that triangle XYZ is congruent to triangle LMNOP or whatever. That was too many letters, but you get the idea. So we're going to do the same thing with similarity today. And there's a new symbol for similarity, which should remind you a little bit of our symbol for congruence, okay? So when I talk about these two triangles, I'm going to make a little triangle symbol, okay? Triangle ABC, because that's my 3 corners of one of my triangles. Triangle ABC. And then my similarity symbol is just like the congruent symbol, but without the equal sign part. So it's just the squiggly line. Okay, it's just a squiggly line, like a up and then a up, like that, all right? So this means similar, is similar to. triangle ABC is similar to, again, I'll grab my triangle symbol here. And then in this case, I need to be very careful about my order of points, right? Now that I've named this triangle ABC, I have a very specific way that I need to name this triangle here, okay? A corresponds with E, so I have to start with the letter E. B corresponds with D, so my second letter should be D, and then C corresponds with F, so my second letter should be F. So triangle ABC is similar to, I almost said congruent, it's not congruent, it's similar to triangle EDF, okay? And from that similarity statement, we know 3 pairs of congruent angles. We also know that from the picture, right? Angle A is congruent to E, angle B is congruent to D, angle C is congruent to angle F. And then we know 3 pairs of corresponding sides, okay? 3 pairs of corresponding sides. AB corresponds to ED, AC would correspond to EF, and then BC corresponds to DF, okay? So your practice problems today are just about naming or creating or finishing these similarity statements, making sure that our points are corresponding, are matching up in order, and then drawing some triangles that are similar, okay? So I would make most of your pictures look like this. They don't have to look exactly like that, but again, one smaller, one bigger. And then naming corresponding sides like I did over here. This side length, arrow, this side length, okay? They correspond to each other. The one thing that I also want to point out to you is that sometimes our triangles are not perfectly, they're not like right in line with each other, okay? So we can do something like this, something like this, and then something like this, something like this. Okay, these 2 triangles here could also be similar. If I marked that with this, and if I marked, maybe that's a right angle. Maybe that's a right angle. And then of course, these vertical angles here, they are also congruent to each other. Wow, that's very interesting. That's exactly the picture for number 4 in your homework. There you go. So just please be aware that the order of the points is really going to go based on what you see in the angles, okay, and how they're marked congruent. So if, for example, this was a AP, sorry, AP, and then this middle point was M, and then here this was X, and this was L. Okay, so I got all these points. If I were going to make a triangle similarity statement, if I start with this smaller triangle here and I just call it, I don't know, XLM, triangle XLM would be similar to what? Well, again, we have to just be careful about the order of our points, and we have to match up the angles that are congruent to each other. Okay, that's what we're looking to do in these statements. XLM is congruent to, or excuse me, is similar to, well, X angle is congruent to A. So I'm going to start with A. And then L is congruent to P, so I'll go P. And then M, I guess, is congruent to also M, right? They're the 2 different angles at that same point. So I'll do that, APM. Okay? So again, we want to be really careful about the order of our points, especially when our triangles are sort of flip-flopped around or like mirrored or flipped over or turned or something like that. We have to be very careful about where our points are at, all right? If you have any questions about similarity statements, how to create them, or what similar triangles means, or similar shapes in general, please reach out to me at some point. Email, phone calls, Zoom office hours, all available for you. Otherwise, that's all I have for you for today, and we'll talk to you soon.